Welcome to this lecture on sensors. So already in the first lecture in automation, we have seen that sensor plays a very important role in the closed control loop. Now the sensors are the measuring instruments that takes the data from the output variables and that's sent to the comparator to take certain control actions. Okay, so sensors are very important things, and there are many sensors those are used. Now I will start this lecture with a small video and then we'll see some of the specific sensors.
Controls engineer, we often tend to see things from the electrical end of things. So in this exploration, we will look at two broad categories of sensors. Digital sensors that return on-off signals, and analog sensors that return a range of values. Our first stop is digital sensors. These are by far the most commonly used sensors in the industrial world. So what is a digital or binary sensor? In theoretical terms, we're referring to something that returns one or more bits of information per sensor. Initially, they were simple. A contact that touched another contact and something got where it was supposed to stop. In those old machines, this often meant 110 volts exposed for the operator to touch, or passing through the machine frame. Unsafe under any condition, and probably illegal in today's safety-conscious world. Later, these became a switch that flipped when something got to a position. These are referred to as limit switches, and are still in use. We use these sorts of sensors for anything that we divide into two states. On and off, true and false, is and isn't. For example, in position, full, empty, power on, and running. Let's look at a few examples of these kinds of sensors. First, as mentioned before, mechanical switches of various kinds are still around. Limit switches are still used in ugly, dirty environments thanks to their armor-plated construction. One big reason they have become less popular over the years is that they're huge compared to many of the other sensors available. Proximity sensors, very often called proxies, are used for detecting close metal objects using magnetic fields. In many environments, these have replaced limit switches and position sensing applications. Optical sensors have a much longer range than proximity sensors, but they are susceptible to dirt and other environmental and mechanical issues because they use light for sensing. We often use them where we are not picky about exactly where the target is, but we need to know it is there. Like boxes on a conveyor, where we don't care where on the conveyor it is, just that it's passing by. Capacitive proximity sensors are like a proximity sensor, but for detecting non-conductive materials. They are very sensitive to contamination, and historically have not been very dependable. Ultrasonic proximity detectors detect solid objects using high-frequency sound, but are very susceptible to environmental conditions and dirt. We don't use them often, but they can solve sensing problems nothing else can. An auxiliary contact is a part of a relay. These tell us when whatever is controlling the relay has turned it on or off. A push button senses the operator's action. For now, that's all we'll say about digital sensors. Most controls are still designed around on-off signals, so these are the bread and butter of a control engineer's life. At one time, cars had no fuel gauge, and you had to have a reserve tank, a gas can, so that when you ran out, you could get to a fuel station. Now, cars all have fuel gauges, and we will next look at the sensors that make that possible, along with many other measurements that automation requires. An analog sensor is one that converts a variable physical quantity into a signal that the control system can understand, a voltage or current. By physical quantity, we mean temperature, pressure, humidity, distance, and speed, among others. There is a general category of sensor for each of these. Some sensors combine quantities, like temperature and humidity, or distance and speed, into a single instrument generating two signals. There are a few general categories of signals generated by these devices. For temperature sensing, the devices themselves produce either millivolt range signals in the case of thermocouples or variable resistances in the case of resistance temperature detectors, or RTDs. Because of their higher accuracy and repeatability, RTDs are generally a better sensing element when we can use them. PLCs have cards that are specifically designed to handle both of these kinds of devices. The rest of the signal categories are converted locally into a more generally understood form of signal, either voltage or current, before being connected to the control system. If the temperature signals have to travel very far to the control system, we usually convert them like this also. The most commonly used standard today is the 4 to 20 milliamp signal because of noise immunity and other characteristics. And every type of analog sensor I have mentioned can generally be purchased in that type of output. We have just taken a whirlwind tour of the primary sensors used in almost every industrial control system. With these sensors, we sense everything from which buttons the operator pushes to the height of liquid in a tank, to the pressure and temperature of steam in a boiler. These sensors and a few others, with their signals processed by hardware and software, control the industrial processes of the world.
So you have seen the different kinds of sensors which are used in industries. Next, we'll see some of the commonly used sensors which are used in many Arduino projects. The first one is the joystick sensor. You have probably seen this joystick sensor. These are basically two potentiometers. Actually, it has two axes, two dimension joysticks. You can see basically two potentiometers are there by which you can control the different kinds of motion. Okay. So basically, in potentiometer, you have seen that with the help of a knob, we can giving certain input signals. Similarly, with the help of a joystick, it is possible to give two input signals at the same time with the help of a joystick. Okay, two dimension means actually there are two potentiometers present in it. Now, Bluetooth module. This is a very useful one because if we want to wirelessly control from our mobile something, then through Bluetooth module, if it is added to the Arduino with the hardware, and on the other side through the mobile, it is possible to using some app and control the robots or cars or whatever that may be. So for this kind of wireless applications, Bluetooth is very important module. Here you can see this is a motion sensor, SW420 motion sensor. It's basically a vibration module, and with the help of this we can sense the vibration present in bearings, gears or different machine components, and this is a very important sensor. This one is a PIR sensor, passive infrared. PIR full form is passive infrared sensor, and in this case in this module actually helps us to identify whether there is any infrared source is present close to it or not. If certain infrared source is present, infrared source means all the body is actually radiating infrared, and depending upon its intensity it is possible to identify that body, and that's why many times this particular sensor is used to identify whether any human motion is taking place or not. Okay, if human body identification, this is a very important sensor. There is a pulse sensor module where it sends the pulse of human pulse, basically the heartbeat, and basically a light sensor is there where light reflects depending upon the how much blood is flowing through the arteries and through the capillaries depending upon the heartbeat. So through this sensor it is possible to send certain medical data. If you, along with this sensor, if you connect certain wireless module like either radio frequency module or Bluetooth or Wi-Fi module, then it is possible to sense certain medical condition of a patient to far distance away. Okay, this is a Hall sensor module, and it is based on the Hall effect, and Hall effect is basically an electromagnetic effect. When certain magnetic field is present, then these Hall sensors actually creates a very small voltage around it, and based on that basically it sends whether any magnetic field is present or not, or if there is any change in magnetic field that can be sensed. In this way it helps in identifying the position, speed of the shaft. Okay, so this is a very useful sensors used in many applications in industry. Here is a sound sensor module. Here it sends basically the sound intensity and accordingly send the signal. So many times this can be used to identify based on whether for a particular intensity or sound is there, and accordingly suppose you want to direct something to a particular robot, then it will work accordingly. Okay, so this sensor is very useful. Then digital barometric pressure sensor, or the BAP sensor, where BAP sensors are used in engines, modern engines, where it is required to maintain a proper airfill ratio. It actually measures the barometric pressure, so it helps in mixing it properly, and this sensor is very useful. Here you can see another one, which is MQ2 gas sensor, where different gases like LPG, propane, methane, hydrogen, alcohol, smoke, carbon monoxide, all these kind of gases can be sensed, and definitely you can understand that this particular sensor can be used to detect whether any LPG leakage has occurred in the kitchen or not. Okay, very useful one. Another one you see, humidity and the rain detection sensor. So if there is any rain, then that will be detected by this particular sensor, and accordingly you can do certain actions. Okay, this is again a speed sensor module and motor speed sensor module. The major goal is to check the rate of an electric motor, but any particular operations that is occurring over and over again, and that can also be sensed. Okay, so it is can be used as a rate meter also, simply measure the rate at which some event occurs. Okay, accelerometer can be used for tilt sensing applications. You know that this accelerometer is also there in our mobile. For certain virtual games, you know that you actually tilt the mobile, and accordingly the car, in a car racing game, maybe the car is also moving in that particular direction, and this is happening because of the accelerometer. So this one is a very important sensor. Now metal detector, you know that metal detectors are used in many shopping malls and others, where it detects whether any metallic objects are there or not, or if certain metallic objects are buried underground, that also can be identified with the help of this sensor. Color sensor module TCS3200 based on RGB sensor, and it can detect, measure a nearly limitless range of visible colors, and many times in industry it is required to separate different coloring objects, and this sensor in that case will help the robots to do all these actions. Alcohol sensors, you know, to avoid the traffic accidents, whether the alcohol consumption has been done by the driver, that is checked. So this is the alcohol sensor, where basically a tin oxide sensor is there, and its conductivity actually changes with the alcohol gases. Now flame sensor is very important, used in fire alarm. You know, depending upon the flame, it will sense. Okay, and here you can see the pin connections of the flame sensors. One pin here you can see connected to the arduino analog. And so flame sensors, you can see it can be both analog or digital. Here you can see the digital also can be if there is flame or not, and here you get basically the intensity of flame, the analog variation. Ground and VCC. VCC is the positive power source, you know. So fire alarm, how will be the connection? You can see that one will go to the power, 5-volt power, another one will go to the pin, another one will be grounded, and one buzzer may be connected. Here you can see, and then depending upon the conditional loop, the buzzer will automatically it will give certain tune that will be sent. Here you can see for the digital, here you can see the digital input pin, and previous one was the analog input pin. Okay, now the buzzer will be set at a particular tune for a particular condition. That program you have to give in the Arduino. Here you can see this is the soil moisture sensor for the agricultural use. This is a very important. If the moisture requirement is there, then with the help of these sensors, when it will be identified, then accordingly the pump can be run or something. Similar actions can be taken. Here basically one potentiometer is there that will adjust the intensity of how much you will set according to your choice. And these are the pin connections. You can see it can be both analog, digital, ground and VCC. And the connections to the Arduino is almost similar to almost all the sensors. One will connect to the pin, another one is power, another one is ground. Okay. Here you can see another one very important, light dependent photoresistor, and this particular sensor looks like this one, and this is very sensitive. It is a resistor which is sensitive to the light intensity, and you can see that this is basically a cadmium sulfide which is sensitive to light intensity, and you can see its resistance actually decreases as the light intensity increases. This graph showing that. Okay, so based on that it will generate pulses, and one can identify that whether it is dark or light, and accordingly some actions can be taken. Okay, so here you can see the connections with the Arduino. One will be 5-volt, another one will be ground, and another one will be the pin, and how the ground and pin is connected to the resistance you'll see. And this is a very important sensor because this can be used to light automatically the street lights. When it will be dark, then automatically the street light will on, and when in the morning, street light will automatically will be off. Okay, so for those projects this can be helpful. Here you can see for automatic room lighting in the evening, these also can be done with the help of LDR. So if light is there, then Arduino accordingly will give certain direction to the bulb, and with the help of a relay the bulb can be controlled. Okay, and here is some data depending upon the intensity. You see the LDR values, if it is in the range of 350, 350, that means in the normal room light. If the finger on the top of the LDR sensor, then its values are very low, and if torch is shown on the LDR, then its value is very high. So accordingly you can create the logic when the light is to be on. Okay, and the circuit has to be gone through the relay. We have not yet discussed what is relay, but definitely we will discuss on how relay is connected with the Arduino and with the electrical instruments like bulb or a fan or pump, whatever that may be. With the help of relays we can connect like large power consuming electrical devices. Okay, we'll see that. Here you can see another one, which is capacitive touch sensor. So whether touch is there or not, depending upon, it will sense the digital signal. Here you can the signal, the VCC, the ground, these are the pin connections. So it is basically a digital read. So whether someone has touched it or not, depending upon that, some indication can go. And these touch sensors are really very useful in many cases where the touch switch, touch pads, those are basically operating under this kind of sensors. Now coming to this temperature sensors, these are very common, though there are many other kinds of temperature sensors. These are TMP36 and LM35, both integrated circuit temperature sensors, calibrated analog outputs. Okay, so both are analog outputs. Linear output use semiconductor temperature sensors. These are semiconductor temperature sensors. Now TMP36 operates on 2.7 to 5.5 volts, and temperature range is -40 to 125 degrees centigrade, and accuracy within 2 degrees Celsius, 10 millivolt per degree Celsius linear output. This is what is the most important information that you have to remember. 10 millivolt per degree centigrade. This is what is the relationship with the degree centigrade. And 500 millivolt offset to allow for negative temperatures. We'll see what is this thing. For the LM35, it is operating in the range of 4 to 30 volts. Temperature range -55 to 150. Accuracy 0.5. It is more accurate, you can see. 10 millivolt per degree Celsius, again the linear, and negative voltages for negative temperatures. Okay, both having the similar VCC output and ground pins like 1, 2 and 3, you can see, and they are connected with the Arduino in a similar fashion. Okay, and an IR module, here you can see this is another sensors, IR sensors, infrared sensors. In this case, you can see this is what is power LED, and this is distance adjustment potentiometer. Basically, that means you change the you can change the frequency. That means the range in which you want to consider your objects. Okay, the maximum range that you can set through this one. And here you can see one LED, which is the emitter, another one is the receiver. So through one LED, basically infrared is emitted, and other LED, which is a photo LED basically, and that will sense the infrared that will be reflected back, and reflection will occur when there is certain obstruction or certain object is in front of it. and based on that certain pulse will go, and accordingly it will sense. Okay, so this is what is the principle. You can see that infrared light obstructed with some object and come back to the photodiode, and photodiode sends it and send it to arduino, and accordingly certain actions can be taken. So this can be used in many obstacle can be identified, or for the line follower robots, so for that this particular sensor is used. Another one, you see, it is ultrasonic sensor, where the principle is that one of them will send the ultrasonic sound, and after triggering that, if certain object is there, then that will reflect it, and that reflection is collected, and but accordingly it is possible to identify the distance of the object. Okay, so not only the object is present or not, it is possible to identify the how much distance away from that position that can be identified with the help of ultrasonic sensor. Here you can see one is the trigger pin, another one is the receiver. Okay, the trigger pin gives a 10 microsecond trigger pulse. This is very important, 10 microsecond, that you have to remember, and then echo pin will receive a certain pulse, and this timing of the pulse will ultimately decide that how much distance away this object is. Okay, if the object is far away, accordingly this distance will change, and that relationship is directly proportional. So here you can see that HCSR04 transmits 8 ultrasonics 40 kilohertz pulses. So we are not going into much detail of all these things, but you have to remember certain informations like 10 microsecond trigger pulse is created, and depending upon the distance of the object, certain pulse will be received in the echo or the receiver, and from this data it is possible to identify the distance. How can we identify the distance? That if we consider the speed of the sound is 343 meter per second at 20 degrees centigrade, then based on that it is possible to identify. So you can see if the speed is 343 meter per second, then this much of centimeter, 0.0343 centimeters per microsecond. So this is what is the speed of sound in centimeter per microsecond. Okay, if it is meter per second, then if you convert it into centimeter per microsecond, it will become 0.0343. That's all. That's what you have to remember. Then if is the total time taken is delta t, this delta t waveform will get this value from the echo pulse width. Okay, so here you see, so this is what is the delta t, 500 microseconds. So that is possible to get, and if we get that, then what we do, in that time how much distance it will travel, this delta t into velocity of the sound in centimeter per microsecond, because this is in this is in microsecond, that will get that multiplied by this. And why we are dividing by 2? Because in that time it actually goes from that transmitter to that object, and again come back from the object to the receiver. So it covers actually double the distance, and that is why divided by 2 is there. Okay, so 500 divided by 2 multiplied by this factor, which is basically the speed of sound in in centimeter per microsecond. That you have to remember. Since this 500 is in microsecond, that you get, then you will get final answer in centimeter. Clear? So here is the connection of the pins of the HCSR04 ultrasonic sensor. You can see the 5 volt is VCC connected, and the trigger pin is there, echo pin is there. Okay, so the trigger pin is connected to pin number 10, echo pin is connected to pin number 13. Okay, and ground is connected to the ground. So this is what is the connection of this ultrasonic sensor. Okay. Now let us make a circuit that will indicate if temperature is more than 60 degrees centigrade and if there is any object within 30 centimeter. That means we want to use at least two sensors here, and one is definitely the temperature sensor that will read the temperature, and another one we want to use the ultrasonic sensor. So with the help of temperature sensors, what we want to do, suppose we want to know whether the temperature of certain object is, whether it is more than 60 degree or not. Maybe if it is more than 60 degree, we will on a particular indicator, say LED. Okay, and if it is less than 60 degree, then it will be off. Similarly, if any object is within 30 centimeter, then we will on a LED, and if it is more than 30 centimeter, then it is okay, maybe then the LED will be off. Suppose we want to do this particular circuit. So let us see how we can do that. Okay, come to our Tinkerpad platform. So let us create a new circuit. So let us simply duplicate the previous one. Okay. Now remove this. Push button. First change the name. Here give the name demo. Temperature and ultrasonic sensor. Okay. Now delete. Simply delete this. connect one temperature sensor. Let's see where is temperature sensor. So here TM36, TMP36. So take that one. Okay, TMP36, since it is giving the analog input, so it will be exactly similar to the potentiometer. So here you can see one end is connected to 5 volt, another one goes to pin A0, and another one is grounded. Okay, and take ultrasonic sensor. So here you can see this HCSR04 is ultrasonic sensor. Okay, so let us connect this ultrasonic sensor. We need this resistance, we need this connection. Okay, now if you see, one is VCC, so VCC will be connected to the five volt supply. Make it red. Then the ground, so just make the ground black, and then trigger pin. Here you can see the trigger and echo. So make trigger to any pin, not required to any PWM or something. It can be any pin. Say we are considering pin 7. Okay, give the color, say orange, and echo pin, say we are giving echo pin to 2. Okay, so this is what about the connection of ultrasonic sensor, and the connection of the temperature sensor also has been done. There are two LEDs, one is connected to pin 8, another one is connected to pin 11. Okay, so now we will write the code. You can write the code either here or in the Arduino platform. That means in Arduino IDE. Let us write it in Arduino IDE. Okay, So void setup, another one is void loop. Okay, so what we want to do, let us write that first, that we want to make an argument if distance is less than 30 centimeters, then loop variable will be on, else it will be off. Okay, then and if potential is more than 60 degrees, 70, then going LED will glow. Okay, so this is what is our plan. Let us do it. So first thing first, that how many different pins that you have to specify. Okay, so the input and output conditions that you have to specify. Okay, first there are two LEDs, so pin mode, what is the pin number for the blue LED? For the blue LED the pin number is 8. Okay, so 8 comma output, because these two LEDs are output. Okay, so let us first define this pin, that distance LED. This is what is the distance LED, right? So distance LED is equal to what? Distance LED is equal to pin number 8. Then int temperature LED, temp LED, that is equal to green one, that is pin number 11. So 11. Okay. Then these two both are output. So pin mode distance LED is output. pin mode, temp LED, that is also output. Okay, then what? Then for the ultrasonic sensor, there are trigger pin. For the ultrasonic sensor, there is trigger pin and echo pin. Okay, so now tell me that trigger pin and echo pin, say int trick pin. Trick pin is connected to pin number 7. Connected to pin number 7, and int echo pin is connected to pin number 2. Okay, so now tell me, this trigger pin and echo pin, they are input or output? See, in trigger pin, from trigger pin basically you know that pulse is created, ultrasonic pulse is created, 10 microsecond pulse is created, if you remember. So trigger pin is basically is output, it is not input. But which one is input? The input one is the echo pin. Okay, so trick pin, that is output, but echo pin, this is not output, this is input. Okay, now what else? The temperature. Temperature pin is there, so int temp pin, and temp pin is what? Temp pin is connected to A0. If you see, temp pin is connected to A0. This green one is connected to A0. Okay, so this is again input. Okay, so temp pin is input. So we have defined the different pin status. So we have defined two LEDs, we have defined trigger and echo, and we have defined the temp pin. Okay, temperature pin. Then one more thing is required, this serial dot begin 9600. We want to see some results in serial monitor, that's why we have defined this serial dot begin. Okay, now let us start. So now come to the main void. So what we want to do? So first thing is that let us find out the distance. So to find out the distance of an object, what we have to do? From the trigger pin, we have to create a 10 microsecond pulse. Okay, so first do that. So for that, what we'll do, we write digital write. That means we are giving certain output to the trigger pin. Digital write. What? Digital write to which pin? That is the trigger pin. This pin. So digital write trigger pin, but before giving trigger pin is high. Then trigger pin will get voltage, but we'll keep it for how many time? Only 10 microsecond. 10 microsecond. So we'll give a delay microsecond. Delay microseconds is a function. You can see that the color has been changed. That means this function existing, and if you put something, it will take that value in microsecond. This is not in millisecond. If we write only delay, then it will be millisecond. But delay microsecond will take a microsecond value. And then what we'll do after that, we have to digital write this is low. That means what we have done is high all should be capital, and that's why you see the colors are very important. Okay, so the streak pin is given for 10 microsecond and then it is off. So this is how the triggering has been done. But before starting this triggering, it is better, previously there is no triggering, to assure it you just write previously there was as if nothing was there. So that means clear all previous voltages if present. So initial two lines, these two lines, to clear the voltages. Clear trick pin. Okay, but this is the point where we have started triggering. Then once the triggering has been done, then what do you have to do? We have to check it into the echo pin, that what is coming, and that depends on the distance of the object. Okay, and that will get in the, so distance or distance sense and that will get in a, there is a function called pulsing, P-U-L is pulse, I-N. So this is a function where you will get that signal. If this is not a distance, basically the duration. I hope you remember that the width that we are going to get, the delta t, in the PPT I have just shown you the delta t amount. The delta t is what is the duration that we are getting in the pulsing. Pulsing of what? Which pin? Echo pin. Echo pin will get this pulse, but this will be in microsecond, that you have to remember. So this echo pin, comma, HI. So in duration, now duration is a variable that has not yet been defined, so that you have to define now. So you can write here that value, and that value can be any float value or integer value, whatever that may be. You can write integer, no problem. Now once this duration has been created, then, or it can be float, you can write float. Now from that time we can find out the distance. So how can we find out the distance? The distance will again be float, another variable, distance. Okay, distance in centimeters, suppose. Okay, distance centimeter. So distance in centimeter, how can we find out that? that will be equal to this duration controls this duration into what, half of that, right? If you remember, divided by 2, duration divided by 2 into what, into the velocity of sound in centimeter per microsecond, because this duration is in microsecond. Okay, remember, duration is in microsecond. Remember, duration is in microsecond. So this into 0.0343. 0.0343, considering the fact the velocity of sound is 343 meter per second. Velocity of sound in centimeter per microsecond is 0.0343. Okay, so if you do that, you will get distance in centimeter unit. Okay, so once you get the distance, it is easy to print that distance in the serial monitor. So what you do, print serial dot print what distance is equal to what, then serial dot print this particular variable, the distance in centimeter, this is what is the variable, and then you write centimeter. Okay, so here this print ln means a new line will be created. Here there is no ln, that means this will be side by side. Okay, so this will be printed now. Next, we have to put that condition so that if the distance is below 30 centimeter, then the blue light will glow. So now control of light. This is the conditional statement. So if statement, remember, starts with this and ends with this. So within that you have to write the if statements, and then definitely there will be something called else. If not, then what? So this is what is the if else group. So if this variable distance, this variable distance cm controls, if this variable is less than 30, if this variable is less than 30, then you take certain action. What action you will take? If this is less than this, sorry, actually your condition will be here. Here will be your condition. Okay, if distance is less than 30, then your action will be within the second bracket. Okay, so if distance is less than 30, then your action will be what? Digital write in the LED. Which LED? that LED is distance LED. So digital write, this LED will take the high value if it is less than 30, and else then what happen? Else distance LED, else digital this will be low. That's all. So in this way the first part has been solved. Okay, now we have to do the second part. What is the second part? Now second part of the problem is basically okay. Now the second part is sensing the temperature reading. For that again we have to some variable we have to select. So the variable is temperature. Variable is temperature. Okay, or temp sensor. So from the sensor it will take certain value. Say that value will be this will take certain integer value, and that value from 0 to 1023, whatever be the value. Okay, so what is that? So that will be analog read, right? Because analog input value, so analog read of that pin. What is that pin? Temp pin or A0. Temp pin. Then so analog read temp pin. Now temperature sensor will get that value. Okay, then this value, so within temperature sensor our values will be from 0 to 1023, any value from 0 to 1023. So now you have to see what is the conversion of these values into degree centigrade temperature. Okay, so first you convert it into voltage. So to convert it into voltage you just define another temp volt, temp millivolt, temp millivolt, temp millivolt. So this is again a float, and this is what? This is simply map of 0 of these temp sense. So this particular value we want to find out corresponding to what? 0 to 1023. This is the range in which the sensor value is taking value, and that has to be from 0 to, so maximum voltage is what? Corresponding to 1023 sensor, the maximum voltage is 5 volt. Corresponding to 0 is minimum voltage is 0. So in millivolt it is what? 5000. So this is what is 5000 millivolt, right? So in this way we get that what is the millivolt data that it is getting. Now if you remember that the temperature and the millivolt conversion is for each 10 millivolt it is 1 degree centigrade temperature. So what you have to do is that temp, another variable that you have to define, float temp degree centigrade. temp centigrade, and that value will be, you have to convert this temp volt millivolt divided by 10. So now it converted to degree centigrade. But if you remember, for the negative value, for consideration of negative value, one offset is to be given, and that offset was 500 millivolt offset. Okay, so if it is a 500 millivolt offset, then what you have to do, this temp millivolt minus 500 millivolt, this was the offset to take care of the negative values, and the whole thing is actually will be divided by 10, then it will become completely in degree centigrade. Okay, so in this way we can find out what is the temperature in degree centigrade. Now you just print that in, you just copy it here and print the temperature values. Temperature is equal to this variable and here the unit is a degree centigrade. Okay, degree centigrade. So in this way we can print it. Now the conditional statement, if else, similar to this one. Okay, so just Control C and Control V. So if this particular variable Control V, if this is greater than 60 degree centigrade, then LED will be high. And which LED? That is temp LED. That means the green LED. Okay, not distance LED, it will be temp LED. This will be high, else this will be low. Okay, so this is what is our program. Now let us check that whether it is okay or not. So you just copy the whole program. Go to the port. Just remove everything. And paste it. Okay. Now see if there is an error. Okay, let's check. Here you can see how can you give the distance. You can change the distance. Suppose at this time the distance is 30 centimeter. You can check there whether it is. So here you can see the distance is 29.55, so it is almost giving the right answer. And we check the temperature value, click on it, zoom it, temperature is 25, and see what is the temperature. It is giving 24.7. This is 24.7. Okay, and stop the simulation and check what is the temperature. It is 24.7. So it is almost the same thing. Now we just change the temperature to see what is the temperature now. It is giving minus 40. Okay, here you can see it is giving minus 40. On the other hand, it is 125. You see it is the temperature 125, 124.9. It's almost 125. So you can see it's giving the same thing. Now you just check whether our LED is satisfying the conditions or not. Okay, so for that you just see, first check with this one, start simulation and see if the distance is below 30 centimeter. Here it is 10 centimeter. You see it is below, it is on. Now if it is more than 30 centimeter, let's go more than 30 centimeter. You see it is now off. Now see, if you come at this condition, what is the distance now? (21.5 centimeters). See, now it is glowing. Now if you increase the temperature to 55, you see now it is off. Now come here, 9.5, it is glowing. Clear? So if it is array, then it is not glowing, it is off. Okay, so below 30 it will on. You see. Okay, now come to the temperature. You see, for the temperature, if it is 25, it is off. Now say 681. Now you see it is on. You go below 60, it is off. Go below 60, it is on. Okay, so in this way we can solve this problem. Okay, thank you. And